Hello. Today we're going to talk about further our conversation about infinities and uh, and why we're here. And where we left off last time, I showed you some Fibonacci, a simple bare minimum superposition that we could put in here to get our up quark value, and showed how the 315, which I showed in one of my last videos, 315 divided into 27 gives you the double boson, and then the 17 divided by the 315, which I give the symbol this, ANSUS, because I discovered it, I can name it. It gives you the electron, and there's your neutrino. And now I went into gluons very vaguely, and if you take this pattern right here and give it the relations, which I explained in my previous video, and you come on down and take this, we go into, really what I'm trying to do is show how the gluon fields create the quarks, and they give the values that they do. Okay, gluon fields, the gluons are massless, but I'm showing the values that they create when they combine with the Higgs field to make the quarks. Why the quarks have the values they do. So you come on down here into this rudimentary gluon fields. We got the 2, the 5, and the 7 will relate to the particles I showed in the other video. And what we're going to do is, although I did a simple pattern of pi, I'm going to go a little bit deeper and show you how pi is connected, because pi and E always show up in physics and nobody knows why, and now you're going to know, because we're about to show you right now. Okay, so if you remember, if you watched any other videos, in E, symmetry broke, which is a good thing, lets us know what's going on at 189. So let's just take the same spirit of E, and because it is argued that E's a more magical number than pi, but I think they're both beautiful. And you come on down, we'll go to 189. In the same way we done E, we subtracted the position with the value. If you just take this, which is 4 times 315, because that's shown to be our principal, that's giving us the W boson, the E, and the neutrino, and you come on down and you subtract these right here. That's what is a muon lepton. Okay? And this right here is your Ti family. Basically. And if you look at the gluon fields, that has beautiful symmetry. It shows the 16 and the 47, which is a muon in your up quark. And when it folds into itself, which is my symbol for 315, you add these up with 6, and F times 60 is your Ti. So we have all 3 family of particles going on. We have some symmetry going on. And you can take these gluons and put them over here. Since that's 2 leptons, that's your muon lepton, and that's your Ti in multiples of a proton. I use, in my analysis, multiples of proton. You can basically do anything you want, but it's going to take you a couple decades to do it. Or any crack computer programmers out there, they can run that. So you add 2 of the muons, values that the gluon field makes, and that's your 16 times 2, and then you can put 7 times 2 to 14, and that right there is a Ti quark. Okay, and we can continue the symmetry. We can just go 38 plus 22 is 60. Okay, that's where our E broke with the 60 times 315. It also had the 52 times 315. So we're finding some symmetry, And things are looking good. And I'm going to go a little bit farther in explaining the really concept of how a true vacuum would fold in on itself and create these values. And that's 16. So 6 times the 315, what we showed over here, is 189. Then you got the 16. Well, let's go into farther explaining this, because the math's beautiful, right? But let's go a little bit farther in explaining why these exist and really what's going on here. Okay? Now, as a true vacuum is folding in on itself, the 27 is coming up here and is being consumed within the creation. And that's what's left is the 57, the 315 into the 17, the 315 and 27, creating the W boson. And basically that's what's going on. So the 74 is actually dividing. So let's go for some more symmetry. All right, 47 plus 27, 74, which is your down quark. So let's take that value and go on into these values. You got 74 and a 60, 810. Okay, you got the 74, 16, 216. Now what do we have here? 810 plus 216, 6210. Okay, let's take this value over here, which is an electron and multiples of a proton, and divide it. And you get, bam, tau quark. Okay, so let's do it again. We should have symmetry both ways. Always look for that when you're trying to discover it with math. You want to come at it at least 3 different ways. Minus 216, well, we got 4, 9, 5. Divide that by electron that we have over here. And you get the quarks again. And that's why pi is beautiful and it works in physics.